So what we're doing right now with next thing with ratios is called proportions. By the end, we should be able to tell I'll write that better. Whether two ratios are proportional and solve for the missing part. Okay, so what is a proportion? A proportion is an equation stating that two ratios are equivalent. Okay, so if they equal each other, that means they're proportional. So there's a couple of different ways we can do this. So right here we have the equivalent ratios 2 to 3 and 4 to 6. Okay, so if I can just multiply them. So right now I have 2 to 3 and 4 to 6. Okay, if I can multiply them by the same thing, they will be proportional. So let's think. What times 2 is 4? Well, 2 times 2 is 4. Does that work on the same side? Is 3 times 2 6? Yes. So those are proportional. So if you can multiply both sides of the ratio by the same number and produce the other ratio, they are proportional. Oh, just write it down here. I didn't make that blank very big. Okay, so as fractions. So let's write our ratios as fractions. So I have 2 over 3 and 4 over 6. Okay, so if I can multiply one fraction or reduce a fraction and produce the other one, they're proportional. So 2 times 2 is 4, and 3 times 2 is 6. Since I can multiply them by the same number on top and bottom, they're proportional. Okay, and then there's a process using cross products, and this is my preferred method of telling if things are proportional. So first they have to be in a fraction form. Okay, and we want to know if they're equal. So I'm going to cross multiply. So I'm going to take 2 times 6 and 3 times 4. Okay, 2 times 6 is 12, and 3 times 4 is 12. And since they equal each other, 12 equals 12, it is itself. So if I cross multiply and the products are equal, the ratios are proportional. Okay, so let's try these ones, 5 to 12 and 15 to 48. So let's see if I can figure out what they multiply by. So I have 5 to 12, and I like to stack them like this, so I have room to go from here to here like that. Okay, I like to work on the left, because it's kind of how you read. So from 5 to 15 is times 3. And let's see if 12 times 3 is 48. No. 12 times 3 is 36. It's not 48. So if you could multiply both sides of the ratio by the same number, I multiplied both sides by 3, so by the same number, but it doesn't produce the other ratio, they are not proportional. Okay. So let's do the fraction way. I have 5 over 12 and 15 over 48. Another way you can do this instead of just multiplying is reducing the fraction. So let's reduce 15 over 48. I can divide them both by 3. 15 divided by 3 is 5. 48 divided by 3 is 16. Okay, 5 and 16 don't share anything else. And 5 over 12 does not equal. That symbol means not equal. So 5 over 12 5 over 12 does not equal 5 over 16. So since I can't reduce to produce the same fraction, the ratios are not proportional. Okay, last way. Again with the cross products, my personal fave. I'm going to take the ratio and put it into a fraction, so 5 over 12 and 15 over 48. I'm going to find the cross products. So 5 times 48, and then 12 times, 15, and I want to know if those are equal. So I take 5 times 48 is 240. Then in my calculator, I put 12 times 15 is 180. Those are not equal. So if I cross multiply and the products are not equal, the ratios are not proportional. Okay? So I prefer this way. I think it's way faster rather than trying to figure out what I can multiply, because what if it's fractions? I have to figure out, oh goodness, what can I multiply or divide fractions by to make them equal? So for me, cross products are a lot easier. Alright, so solving proportions. So this is kind of like that percent of a number type of problem. So if I don't know what they are, but I know I want them to be proportional, what does that value have to be? Okay, so I can use mental math. I can find the quotient. Man, I did not make these blanks big enough today. Between 8 and 24. So since the x is missing on the right, I want to take the right divided by the left. So I'm going to take 24 divided by 8, which is 3. So I know that 3 over 8 equals x over 24. Okay, 8 times 3 is 24, so x is going to be whatever 3 times 3 is. So x equals 3. Sorry, 9. 3. There we go. So sorry. There we go. That looks better. Okay, and if I want to check my work, I'm just going to write those two fractions. 3 over 8 and 9 over 24, and I'm going to cross multiply. I'm going to take 3 times 24, and I want to know, does that equal 8 times 9? Okay. So I put in my calculator. Three times 24, and you get 72. And then 8 times 9 is also 72. 72 equals itself, so yes, I did that right. Okay, so x equals 9. All right, and then back to using cross products to solve. This is exactly like those percent of a number problems, okay? So, first up, I cross multiply. I take 7 times x equals, and I know they're equal because I want them to be proportional, so they have to be 13 times 21. Okay, 7 times x is 7x equals 13 times 21 is 273. Okay, now I'm just going to solve for x. So I'm going to divide by 7 on both sides. Get that. X equals 39. And I got to check my work because we like to be precise here. So I have 7 over 13 equals 21 over what I think is 39. I'm going to use cross products. I'm going to take 7 times 39 is 273. And I want to know, does that equal 13 times 21? Which is also 273. Yes, that works out. So now I can put a box around the answer. 3 is 9. Okay. We can also use these methods if they're not given in fraction form, okay? So I'm going to take my first ratio. I'm going to rewrite them so they're bigger for me. So 2 to 3 and a to 15. Again, I like to stack. So I'm going to find the relationship from 3 to 15. That's times 5. So I know that a is going to be whatever 2 times 5 is because I have to do it on the same side. So a equals 10. Okay? And then let's do this last one as setting up as fractions and then solving with cross products. So I'm going to take 4 over 7 and y over 77 and then cross multiply. 4 times 77 is 308 equals 7 times y is 7y. Then to solve, I divide by 7 on both sides. That gives me 1y is 308 divided by 7, which is 44.